Alrighty, good day everyone. Hopefully you're doing okay so far. Today we're going to start our brand new chapter on chapter 5. So this is going to be the last thing that we're covering basically for the course. There's going to be a couple odds and ends that we'll tie up here and there, but the bulk of our time will be spent going over chapter 5, which is all about something called a polynomial. Now, we haven't talked about what polynomials are yet, and it might be a new term for you. So the first thing we're going to do is get everyone up to speed on a bunch of things that we're going to talk about. So if this first part seems a little slow, don't worry, it gets more interesting, but this is basically going to be the start of any sort of advanced math that we're going to be doing from here on in. It's going to be something called a polynomial, and to an extent you've already worked with polynomials even though you didn't know about it. So to start, we have a variable. So probably most of us know what a variable is at this point. It's a variable and we represent it with a letter, and it's a value that is an unknown real number. So the most common one that we're used to is x, but realistically I can use any number I want to represent anything. So oftentimes we'll use t is equal to time. In science, n will refer to the number of something. So if we're counting something, we might use the letter n. X, Y, and Z are good coordinate axes to show position, but the key takeaway is a variable is just a letter that represents something real or something that we want to measure, but we don't necessarily know the number, or the number can change depending on how we're looking at something. The next thing that's important for us is something called a term. So a term is a number or a product of a number and a variable, and I can raise the variable to a power. So basically a term is an individual chunk of numbers where I can do a couple things to it and it'll come out as one number. So examples: 5, 2x, negative 3x squared, minus 2x times y. So notice even here I'm like technically 2 times x times y. I'm doing a number of operations, but realistically this is one number that I'm going to add together. I'm going to get ahead of myself, and for the polynomial, if I put all of this together and I had negative 3x squared negative 2xy plus 2x plus 5, this whole thing here we're going to call the polynomial, and I'll get to that in a second, but basically each one of these here is a term. And this is going to be important because we can do things with terms that are the same or similar, and our goal is to make things as simple as possible for us. Next up, we have something called a coefficient. So a coefficient is a term is the numerical factor. So it's the to put it simply, it is the number in front of the variables. So for example, I have a couple things here. So I have a couple terms. I have 5x. The coefficient is the number 5. I have x squared over 3. The coefficient is the factor, so there is a little invisible 1 here. So it is the number out in front. Or another way I could write it is 0.3 repeating. Negative 1.3xy. I take the value including the negative sign, and that is my coefficient. A couple of things. If you have something like negative y, I can't just say the coefficient is negative. There is a hidden number 1 being multiplied here, because 1 doesn't change anything. So if our coefficient is 1, we generally leave it invisible in the term. So if our coefficient equals 1, it is invisible in the term. So we don't write out 1y or negative 1 times y, we would just write negative y. And the reason for that is that negative 1 or positive 1 times something doesn't change the value of what it is. Whereas if I multiply something by 5, it is going to change the value. And then lastly, if our term is just the number, then my coefficient is also the number, but this is something special. I refer to this as a constant. And this is what our blob of text below is saying. So a constant is just a number that does not change. So the way you can think about it is that there's no variables. It'll always just be 3. The last one I'll give is just a very simple add-on. So if I just have, say, x all by itself, again, there is a little invisible 1 out front, so the coefficient would be 1. And that was a terrible drawn one, so I'll redo it a little better. So first part, just get in mind of keeping in your brain what a term, a coefficient, and a constant are. So a term is numbers, variables, and powers together. A coefficient is a number only. From a term. And a constant is a term that is only a number. The reason why this is important is because when we talk about polynomials, we'll say things like collect like terms or multiply the coefficients by this number. So rather than us having to think about what that's saying, it is helpful if we're really keyed into, oh, he wants me to collect like terms, or I need to collect like terms to do the next step. So I need to find all the things that are the same and put them together rather than thinking, am I thinking about constants? Am I thinking about this or that? So while it seems simple, just make sure you're practicing it a little bit so that you're understanding what each of those refers to. Now we're going to get into some new stuff. So polynomials have a couple of flavors. So we can say types of polynomials. So the first one is what's called a monomial. So mono comes from the old, I think it's Greek word for one, or might be Latin. Either way, it means one. So a monomial is an expression of the type a times x to the power n, where a is a real number constant and n is a non-negative integer. An easier way to think of these is that they are one-term expressions. So they have a couple of examples. These are all separate. So imagine them with a big divider. So I have 3 over 4 y squared is a monomial, minus 4 or negative 4 is a monomial, and 2x again is a monomial. The key bit is that a can be any real number, so it can be, say, 2, it can be negative 2, it can be negative 2.22 repeating, it can be pi. What it can't be is, well, it can't be imaginary numbers, but basically any number I put in front can be fine. Where this gets a little bit more challenging is that x has to be in the numerator, so I can't have it in the denominator, so variables are all in the numerator. So what that means is we're not dividing by any variables. And we aren't square rooting variables are the big ones. So examples of non-monomials, so these are not polynomials, things like 1 over x, or the square root of x, or x to the power of 2 divided by 3, or x to the negative 1. So key bit, our powers have to be non-negative. I can, however, have x to the 0, because remember x to the 0 just equals 1, and 1 is a-okay. But it can't be negative, so I can't have x to the negative 1, and it has to be an integer, so it can't be x to the 0.7. That also won't work. So that is one type of polynomial. I'm gonna split this up. There's two other types. There's what's called a binomial and a trinomial. Binomials are two-term expressions. Like a bicycle has two wheels, a binomial has two terms. So it follows the same rules as above for monomials. So for an example, I can have x squared plus 1. Or I can have y minus 2. Trinomials, tri meaning 3 like a tricycle, so this is a 3-term expression. So an example might be x squared plus x plus 1, or x plus y plus z. Notice how I don't have to have a constant, I can have different variables. I can also have something like 2x minus 2x, or 2y, plus 7, it's fine. Now, all of these are polynomials. We separate monomials, binomials, and trinomials because they can be a little bit special and that we see them very often. But they're still polynomials. So a polynomial is a monomial or a combination of or differences of monomials. So this is, put a little bit simpler, an expression with one or more terms. So for example, they have 3x, they have 2x minus 1, they have 4x squared plus y plus 2. So this is a monomial, a binomial, and a trinomial, but I could also have 4x4 plus 3x3 plus 7x squared plus 8x negative, take away 14. I can keep writing terms, and that is still going to be a polynomial. So starting here, we're going to go on to a different way that we can use to help us both write and read polynomials. So to read and write with polynomials, it's important to know two things. One is the degree and something called the leading term. So the degree is the sum of the exponents of its variables. So for example, I'll give a couple here. I might have x squared. This has a degree of 2. There's only one variable. If I had x, the degree would be equal to, take a moment, think about it. Again, there's an invisible number here. There's an invisible power 1. So this has a degree of 1. a different way I can think about it is if I have 2x squared y, I'm only concerned for the variables. So I see there's a 2x here and then there's a yx1. So I add those together, so the degree of this one is equal to 3. And then lastly, I can have x to the 3, y to the 2, z to the 1, and this is going to give me a degree of 6. So the leading term, what the leading term is the first written term in our polynomials. And we always want to write starting with the highest degree and going all the way to the lowest degree. By the way, I'll do one more example here, just as a quick question. If I gave you the number 6, what's its degree? So think about that for a second. It's a little bit harder to tell, but for this one, there's no variables. So there's no exponents. So the degree in this case is equal to 0. So when we write these terms, the leading term is going to be the first one, and we're going to put the highest degree term first, and then we're going to go with the next highest, and the next highest, and the next highest, and we're going to work all the way down to the lowest. So for example here, I have 5x squared minus 3x plus 4. So I have 3 terms. So I have term 1, term 2, and term 3. The degree of each of them, I'm going to look at each one separately. So 5x squared has a degree of 2, negative 3x has a degree of 1, and 4 has a degree of 0. So the leading term, the one that I want to put first, is 5x squared. And when we ask for the degree of a polynomial, the degree of the polynomial is the same as the highest, or as our leading term. So we want to write these properly. So one of the things I'll write out is it's incorrect to write out negative 3x plus 5x squared plus 4 as a polynomial. Even though it says the same thing, it is not written in the proper way, so it makes it much harder to work with. So we have to, at this point, rearrange. So I would want to put the 5x squared first minus 3x plus 4. And where we're going to be rearranging stuff like this. So for example, here I have negative 5 plus xy. So I have 2 terms. I have term 1 and I have term 2. So I have negative 5. The degree is 0. And how I got that was that there's no variables. Here I have x to the power 1, y to the power 1, so I have 1 plus 1 gives me 2. So my leading term that I should be writing is xy, and the degree is 2. So the proper way to write this would be xy minus 5. All right, here's our special types with a couple of examples. I've already talked about them. So we have monomials, binomials, and trinomials. So just keep that in mind. And this has a couple of examples, so they have boxes of each ones and different ways that you can write them. So you can see just how much variety comes around. But you'll notice the monomials all kind of look the same, or they have the same kind of shape, I'll call them. Binomials look similar in the fact that they have this 2 sets of numbers, and there's always going to be a plus or a minus in between. This one did all minuses, so we can add one more. So something like x plus y would be a binomial. By the way, the leading term doesn't have to be positive, so it is totally fine. I'll add one more here for me to have negative x squared plus 3x minus 4. That's fine. That's a-okay. It's not optimal, but it won't be the end of the world, and it's still a valid polynomial. So we usually write it in descending order of powers. So we have, like I said, the proper way to write it is we start at the highest degree and then we go to the lowest degree term. But what happens if I have something like this? So I have xy plus y squared plus minus x squared. If I look at the degree of each of these, I'll say d is equal to 2, d is equal to 2, d is equal to 2. So I have 1 plus 1 here. I have 2, I've got 2. And they're all different. I have x's, I've got y's, and I've got combinations. So in this case, what do I put first? The convention is alphabetical order. So just like how it's kind of clunky to write yx, it's valid, it's equal to xy. We generally write it as xy. So in this, I want to alphabetize it. So x's come before y's, so I'm probably going to write it as negative x squared plus xy plus y squared. So I'm just rearranging, so I'm doing all my x's first and then all my y's second. When they cross over, you can see that I have both, but after that point, I have no more x's, and before that point, I have no y's. All right, Algebra Tiles, we're going to skip for now, but that might not always be the case, so in grade 10 you might see them, so keep that reference in mind. Or if you want to try any of the practice problems, that's the key page to go to, is 159. It shows you all the positive values are the filled in gray ones, and that this is x squared, this is x, y, and 1. And then likewise, negative x squared, negative xy, negative x, negative y, and then negative 1. With that, you can make a whole assortment of polynomials, but for now, I'm going to skip them and go towards like terms. So this is going to be kind of our last couple steps. So key idea is we want to work with things of like terms because we cannot combine things that are not like terms, or we say that they're unlike. So like terms have all of the same variables to the same powers. The coefficient actually isn't important, but for example, 5x and 3x are what we call like terms. If I think of x as xylophones, I have 5 xylophones and my friend has 3 xylophones. So if I wanted to calculate how many total xylophones I had, it's easy for me to work with. Another way I can think about it is I have 2x squared and then negative x squared. This is also because they're both x squared. Third one, I have 2xy and then minus 4yx. So the key thing is that I'm looking for the same variables and the same power. The order doesn't matter so much because this is the same thing as negative 4xy. So these are like terms. Additionally, I have xy squared and then y squared x. How about this? They say it's a like term. Keep it, again, I can rewrite this as xy squared. Now, each individual variable, notice how the x's and the y's have different powers. That's true. The x's are to the power 1 and the y's are to the power 2. But between the two, both y's have power 2 and both x's have power 1. So that is what we are looking for, and this is what I mean by all like terms have the same variables to the same powers. I don't need to have x squared and y squared so long as all my x's are to the same power as each other and all the y's are to the same power as each other. So by contrast, over here we have x y squared and then x squared y. So I notice that my x is to the power 1 here and x is to the power 2 here, and y is to the power 2 here and y is to the power 1 here. So this is not something I can work with. Additionally, if they're to different powers, right away I can discount them. One thing to watch out for, don't just look at the power because you might mix up this question here. So x and y, they're talking about different things, so just because they're to the same power doesn't mean I can work with them. Another thing to be cautious of, all the variables have to be the same. So if they share 1, like in this case where we have 2xy minus 3yz, sure there's an x and a y, and this one has a y and a z, so they share a y, but this one doesn't have a z and this one doesn't have an x, so I can't work with it. So similarly, I cannot say, or another example, x, y, z and x, y are unlike terms. So they have to have the exact same variables. This one has no z. So even though the x and the y are the same, because it's missing the z, I cannot include it. Now, the important thing, the key takeaway for this section is that like terms can be added and subtracted, but unlike terms cannot. This is basically super important for the rest of math. When we work with variables, we are looking for like variables to add together and subtract, and we want things to simplify down into like variables because we can work with them. And unlike terms, we cannot do this too. So for example, I have 3x squared plus 3x, or 4x squared plus 3x squared minus 2x squared. The x squared is some common variable. If I was to put context in this question, it'd be like saying Jackson has 2 boxes of x, or 4 boxes of x squared. Alex has 3 boxes of x squared, and 2 of them get taken away. So how many in total are left? I can treat this by adding 4 plus 3 minus 2, which is going to give me 5. So the solution to this is that there are 5 x squares. Now, that's if they are common, I can work with them nicely. So here, I have, to simplify, 4x and then 3x squared and 2x squared. So the like terms, I'll circle in green, so I have plus 3x squared, and then I have minus 2x squared. 4x is unlike, so I can't do anything with it. So I can add together these, but I can't add this. So to put this together, 3 minus 2 would give me 1x squared. The 4x I can't touch. And then I'm going to rearrange this. So I'm going to simplify it. So I can drop the 1 on the x squared. And so I get x squared plus 4x. And one of the things that I did was highest, sorry, my writing is a little bit thick here, so I'll highest power first. So one of the things you'll notice is that I didn't write it as 4x plus x squared. I flipped it around so that I put the highest degree term first, because this has a degree of 2 and this has a degree of 1. So one of the things about simplifying is that you rearrange it in order. Last one. This one's tricky. I'm going to look at my variables first. So I have x and y squared, and I have x squared and y, x squared and y, and x and y squared. So what I like to do is I like to circle and connect the things that are connected to each other. And sorry, I just want to include that plus. So I've circled my like terms. So now what I can do is I have 2xy squared plus xy squared. So I'll call this one 1. So 1 is this piece here, and then I'll call this one 2, and what I'm doing is right here. So then plus 3x squared y minus 4x squared y. So keeping this in mind, they have the same degree, but what I'm going to end up with, if I carry this through down this way, I'll have 3xy squared, and then this will be negative x squared y. And then my last check is order. So one of the things I'll notice is both have the degree equal to 3. So I'm thinking alphabetical. They both have x's, but I notice that this one has x squared, whereas this one only has x to the 1. So I want to put negative x squared y first, and then plus 3xy squared. So one of the things you'll notice is that my x's, which come before y's, start at the highest number and they get smaller and smaller and smaller, and the y's get bigger and bigger and bigger as I go this way. Okay, so that is really the key parts of 5.1. We're just learning how to simplify and work with these sort of larger equations with multiple variables. So as practice, what I want you to try, 1 is really good. It's mild, so I'll circle it in green. And basically it's matching, so just try all of them. 2, determine whether or not it is a polynomial or not. So does it follow the rules that we were talking about? 3, it wants you to determine the degree of each polynomial, and one thing that might help you is to simplify first if needed. You might not have to. 4, determine the coefficient. So this is remembering what our coefficients are. 5 is a range. So this is our highest degree to lowest. We are skipping number 6. We have no time for algebra tiles. 7 is also algebra tiles, so just skip them. 8 is our simplify, so this is what we call collecting like terms. That's the key part here. You also want to make sure they're in the proper order. And 9 we're going to skip, and then 10 is kind of the culmination. So simplify each polynomial by collecting like terms. So these are the more challenging ones. So take your time, give these a go. The next video will be covering 5.2, where we actually learn how to do stuff with polynomials. And this is going to be the bulk of where our assignments and quizzes and tests are. So we're going to only spend a little bit of time on the first chunk of identifying, because we're going to be using all of this stuff continuously when we solve harder and harder things. That's all I have for you today. Take care, stay safe, have a good one. Bye.